So, welcome back guys, and I do hope you and your family are well. So, what we're going to look at today is some electrical components. Now, you might want to pause the video straight away and just check that you know all the circuit symbols for different electrical components we deal with at GCSE. It's important you know those because you're often asked to draw them, or in an exam they draw them for you and they say, "What's this?" Now, you might remember on the front of my classroom, there's this circuit board that I've left at the front for years and years, and I leave it there so students can have a quick look and begin to recognise things. And this circuit board is covered in lots of electrical components, many that we'll do and some we won't. And there are fixed resistors here. They're usually sort of stripy things. There are things you can turn with a screwdriver, too small to see, which are variable resistors. There's LEDs on here that will light up when it's switched on. There are thermistors on here that measure the temperature of the circuit board. So what I'd like to do is I'd like to quickly whiz through those electrical components, show them to you, and show you what they do. So let's kick off with a fixed resistor. They come in all shapes and sizes, but you know the circuit symbol is that a box with two wires coming out at the end. So here's one on a piece of wood that kind of looks like that. So it's a fixed resistor. You've really got to get into your head that the fixed means fixed. In other words, if we turn up the amps, the resistance stays the same. Okay. If we turn up the volts, we'll get more flow through it, we'll get more amps, but the resistance stays the same. It consists of a wire inside that's not a very good conductor of electricity, and that's what makes it a fixed resistor. It has resistance. It doesn't like electricity passing through it. It's not a particularly good conductor of electricity. Okay, we talked in class as well about a variable resistor. These are the ones you sort of turn to make lights brighter and dimmer. So I've connected it up to a lamp. Don't worry too much about the circuit. So let's connect it up, doesn't matter which way round, with a lamp. And you turn the variable resistor, and you must know that that means there's more resistance in the circuit, and here there's less resistance in the circuit. So a variable resistor conducts electricity better when its resistance is lower, so that's that one. And when its resistance is higher resistance, it restricts the flow of electricity and conducts worse. And in this case, the lamp is pretty much off. So that's the variable resistor. The LED, well, we've dealt with LEDs quite a bit. And I'll just get myself some wires here. So here we go. And the LED is an interesting little creature. Firstly, if you connect it up to a battery, and I'll connect the positive side of it to the plus, and the negative side to the minus, it lights up really well. So that's the first thing you need to know. Secondly, if you connect it the wrong way round, so I'll connect the minus of the LED to the plus and the plus of the LED to the minus, it doesn't work. Okay, it's a one-way electrical device. Do you remember the symbol had that arrow in it? And that arrow shows the direction that current will flow from plus to minus. Can't go the other way. It has another really interesting feature. I'll just wire it up again. And one that confused me when I was much younger. That it doesn't light at all with one cell, one battery. And when I was younger playing with these, I had no idea what was wrong. Until I increased the voltage and it began to light and got brighter and brighter. So what that means is the LED only conducts in one direction. And even if you get it the right way round, with a small voltage it doesn't conduct. You have to get a voltage that's high enough to make it conduct electricity. So the right way round, it needs, shall we say, about 1.7 to 2 volts to start to light. And then higher voltages just make it brighter. Let's have a look at another device. This is an interesting one. This is the LDR, the light dependent resistor. Now, don't get it into your head this is a solar cell. It's not. I can sort of prove that by connecting it up like this, and the LED doesn't light. Okay, doesn't matter which way round you put the LDR. It's not a solar cell. It's a light dependent resistor. Okay, in other words, its resistance changes depending on how you put light on it. So I'll just connect it into the circuit. I need one more wire. So it's a series circuit. Here we go. Oh, plug came out. That's that one. Okay, and there's the LED, and there's the LDR, and I'll cover it up. I'm looking at my screen, and the LED goes out, and I'll uncover it, and the LED comes on. And if you cover it up a bit, or you get a dim LED, and if I turn it to the window, I think we probably get more light. I'm looking at my screen again, and less and more. So have a think about how the LDR works. Okay, at the moment there's light on it, and so it conducts well, so its resistance is low. And if its resistance is low, we get a good flow of current and the LED lights. If I make it dark, the LDR's resistance goes up, its resistance goes up, it doesn't like electricity going through it, and therefore the flow of electricity, the amps or current, is lower, and the LED doesn't light. There's a good way to remember these in exams, and my kids in Scotland taught me this. LURD, L-U-R-D. Light up, resistance down. Okay, so if the light level goes up, its resistance goes down. LURD is a good way to remember it. And the opposite's obviously true, that if the light level goes down, its resistance goes up, and it doesn't light very well. Okay, that leaves us with one more device, and I'll just hand wave this in front of you because time is short. Okay, this glass tube contains two wires, and in it, right at the end, is a material that is sensitive to heat. So this is a thermal resistor. It's a thermistor. Okay, the thermistor's right in the tip, and I shall never forget my kids in Scotland shouting "turd" at me. I thought, what's going on here? But what they were saying to me was, I thought, why turd? I can't do it in a Scottish accent, you understand. Because I thought that was a bit offensive, really, and they were lovely kids. But no, they were making a really good learning point to me. Turd, temperature up, resistance down. Oh, I've got it, okay. Temperature goes up, I make it hotter. Its resistance goes down, it conducts electricity better. The amps goes up, and an LED would get brighter. Okay, and the opposite is true. If we were to put this in iced water, okay, it would get colder. Its resistance, its restriction to electricity would go up. It would conduct electricity less, and the amps would go down. Its resistance would be higher with low temperatures. Okay, what would we use this for? We could use it in a hospital situation, put it in your ear, and temperature would change on it. And if we knew its resistance and we knew what temperature that represented, we could work out the body temperature. It's one of the ways of producing an electronic thermometer. We could put it maybe in a fridge, and when the resistance goes up and up and up, the fridge knows it's really cold, so it switches off the cooling system. And when the fridge gets warmer and warmer and warmer, the resistance of this goes down, more electricity flows, and it turns on the cooling system. So that's the thermistor. So a quick lesson, that one, on electrical components, and I'm sorry we're not here together to try them out and build some experiments and make some measurements. But the main thing is, learn the circuit symbols and then go back through my video and pause on every electrical component and be absolutely certain that you know what each one does. Anyway, I look forward to seeing you again very soon.